Hello, my name is Joe Vasta, and I'm going to talk about the Pythagorean Theorem. The Pythagorean Theorem has to do with right triangles. A right triangle is a triangle that has a right angle. A right angle is 90 degrees, so this right here is a right triangle. A and B on this right triangle are referred to as the legs, and C is the hypotenuse. So what the Pythagorean theorem says for this right triangle is a squared plus b squared equals c squared. Okay, we could use different letters, x, y, and z or whatever, but that's the Pythagorean theorem. Pythagorean theorem is very useful in the real world. It's where you kind of start off when you're learning trigonometry. Even one of the presidents of the United States has a proof of the Pythagorean theorem. That would be President Garfield. There are actually hundreds of proofs of the Pythagorean theorem, and what I'm going to do is I'm going to show you two of those proofs. And a proof is just showing you where that a squared plus b squared equals c squared comes from. So let's continue. A proof of the Pythagorean theorem. So let's start off with our right triangle. What I'm going to do is put more of those same right triangles on this slide. Okay, so look what we have here. We have 4 of those right triangles, and we have this object that appears to be a square in the middle. It is a square. We can make this more rigorous, but the bottom line is the angles of any triangle add up to 180 degrees. And you've got 3 angles right here that I'm hovering the pointer on. Those same 3 angles would happen to be this guy right here, the right part, the right angles right here, and the other part's right there. So those 3 angles there add up to 180 degrees. So we do know that this is a right angle, and thus this is a square. What we're going to do is we're going to rearrange these 5 shapes, and we're going to put them over here. Okay, so those 5 shapes can be arranged. Okay, I'm going to take 2 of the right triangles and put them together to form a rectangle. So I do that. I'm going to do that again with the other 2 right triangles. So we have another rectangle. And then the square. So the thought is the area of this big square should equal the area of this rectangle plus the area of this rectangle plus the area of this square. So now we turn a little to algebra. We're going to go ahead and figure out the area of this big square. Well, it's not that bad. The area of a square is side squared, and so the side of this big squared is a plus b. So we see it right here, a plus b. So let's go ahead and write that down. A plus b times a plus b, or a plus b quantity squared. There it is. Now that should equal the area of these 3 guys. So the area of this rectangle, length times width, a times b. The area of this rectangle, a times b. And the area of this squared is c squared. So let's write that down. On the left-hand side, I'm going to multiply that out, a plus b times a plus b. And on the right-hand side, I'm going to combine like terms, combine those 2 ABs, and we have that. Okay, so we have an equation. I'm going to subtract 2AB on both sides of that equation, which has that result. And we end up getting a squared plus b squared equals c squared, and this completes the proof of the Pythagorean theorem. We are going to do another proof of the Pythagorean theorem. Actually, that's going to be my favorite proof, and we'll see that on the next slide. Another proof of the Pythagorean theorem. I have that right triangle. I'm going to throw it inside a big square. Okay. What I'm going to do is I'm going to put 3 more right triangles in there, and it's going to look familiar. It's going to look kind of like the last proof, but it's a little different. It involves less algebra, this proof. So let's put those 3 triangles in there. Okay. I have a big yellow square in the middle that has area c squared. So the yellow area is c squared. So that means what I can do is I can move around some of those triangles, and that yellow area should remain c squared. So let's do that. The yellow area is c squared. Okay. I'll move some things again. The yellow area is c squared. Let's do it again. Well, look what I did. I just put one of the triangles on top of another one. So the yellow area is not c squared. Let's correct that. It is not c squared. So you have to be careful when you move these triangles around. What I'm going to do is I'm going to put them back the way they were and move them around a little bit more strategically. So there they are. Let's watch the show. So I moved the bottom left triangle up to the top right triangle. Now I'm going to move the bottom right triangle over, and I'm going to move the top left triangle down. That yellow area is still c squared, but look what that yellow area is. It actually is 2 different parts, 2 different squares. And so the yellow area also equals the area of this squared, which is a squared, plus the area of this little yellow squared, which is b squared. And so this completes another proof of the Pythagorean theorem. I hope you enjoyed this video.